Okay, so I will start. This is the first meetup of the Require LX in 21. The last was in November. So we are super happy that we can come back, although not physically there, but online. And we have so much people online with us. As Zé said, it's really warming to know that you guys are here and we can chat with each other. So for today, we have a talk from David, but also this is a moment where you can check with your peers, bring something to the table if you want, share something, and have a beer or a coffee if you have it at home. Because sadly, we cannot provide that anymore. We will in the future, we will. Okay, so my name is Sada. I'm usually the host for this meetup, and feel free to reach me through the chat box or through email or via the channels that we have. If you have anything to ask, to add, and also this is pretty informal. So if you want to keep your cameras on, keep it on. If you want to keep it off, it's okay. If you want to participate, please add something in the chat box or just raise your hand or just call out David or David Alecrim or us and someone will let you participate. So let me move this. Yeah. Okay, so as for the organization, we have always this kind of open topics for everyone. If we have a Slack, we are not using it so frequently because people got silent, but if you want to participate, send something, please, you can use it. If you have anything that you would like to see explored, and we usually work with talks, but if you have another format like a workshop that you would like to give, a game session, an article, please share with us. This is an open community and an informal one, so not here for any judgmental on any format. We like to experience new things, so experiments are welcome. And unexplored subjects, even if it's not related to the topics that are generally talked about, if you have other topics that you would like to discuss. And also on an organizational side, I can tell you that we are talking about starting to move forward to other different topics. So if you have any idea, please share. Or a talk on a subject that you would like to share, a recent project you participated in that you would like to share your experience or your recent learnings, anything that you think that it might be useful to this community. Today, our guest, David Alecrim, to talk about Micro-Frontends with Model Federation. But first, and this is my mistake, I need also to talk about something before we go to the vid. So we have like an article club. This is something we're trying to implement recently. I know that there's a lot of reading involved on all of our work as developers. So if you have cool articles that you would like to share, discuss, debate, or bring to discussion, even to say you don't agree with it, please do so. Share the link for the article up front so we can create a moment for discussion. And also today, if you would like to discuss something, we still have time for that after David's talk. So this is pretty open format. Don't feel constrained by anything. And we can pass on David. And I was forgetting also something that I would like to do. If it is okay for everyone to record this session, David's talk, if anyone disagrees, please put it on a chat. Don't do it. But usually people are quite okay. The recording will go to our YouTube channel and will be provided to the Kia group as our partners for today. And I forgot about to mention also our partners. So we are partnering with X Geeks, a Kia Group company today. Rita is representing them here if you have any question about it. Rita, I don't know if you want to mention anything before.
Thank you, Sara. So I just wanted to highlight that XGeeks is a KI group company in Portugal. We also have KI Challengers, which we have some people attending too. So if on behalf of KI group, I hope you enjoy it. And of course, then follow us and check our work and all of that. And check these guys also, which I'm pretty biased, but they're very cool engineers. So I think they're worth to take a look at. And I think I think this is it. Yeah. Thank you, Sarah.
Thank you. Also, a partner that has been with us for a long time now. It's MeMsql. I don't know if we have anyone from MeMsql. If we do, raise your hand, and we can go to the speaker. So David, thank you, and I will stop my sharing so you can start your talk. Thank you.
Okay, thank you, Sarah. So I'm going to share now. Can you guys see the screen?
Yeah. Yep.
Okay, so let's start. So I'm here today to talk to you about Micro-Frontends, as Sarah said, and how to leverage Webpack 5 together with Module Federation. So before I actually go into the content, my name is David, as was mentioned. I'm a senior software engineer at XGeeks. And the talk that I'm going to give today is like an experience that's happening currently in a client of ours. And I also left some of my contacts here in case you want to reach out after the presentation. Okay, so just a really quick introduction to Micro-Frontends. It was a term first coined by ThoughtWorks. It was introduced in 2016, actually, when they attempted to bring out the microservice architecture, but adapted to the front end in order to bring out the advantages that they saw in the microservice architecture. It's currently being used by some big names like Spotify, Zalando, SoundCloud, Dazen, and it's really still a polemic subject, as in many subjects in our area. And you can have here a look at some random comments on the internet, on Reddit, regarding microservices. Some of them say, well, you don't need to implement this in your organization. You don't have the capacity to implement this in your organization. You most likely don't need this. There are other ways. And yes, there are hundreds of ways to do solutions to the problems that we have. But overall, the benefits that we wanted to bring out in our client by using Micro-Frontends were threefold. So to get independent deployments between our different teams, our product teams, to get less interdependency between these teams that work in the same platform at the client, and also to get better scaling. And this scaling is both for the teams and for the platform. So we want to achieve better scaling for our teams, which are growing and will keep growing even more. And also for our products, in order for them to be able to be more independent and have more liberty to implement stuff and get features done to the clients. Okay, so I'm going to give you a bit more context regarding the client and where we were and why we did some of the decisions that we made. First of all, we were working in small teams a while ago. We had our front end, back end, and infrastructure horizontal layers, which means that our front end team was working on multiple separate projects on the same platform. And then the back end was doing the same together with infrastructure, which supports the whole APIs and the front ends that are deployed for the client. And when we decided to investigate and do some actual changes in the way of Micro-Frontends was after around 2 years of development in that client. And what we wanted to do was to achieve a vision more like this. So we wanted to do more vertical teams regarding each product. So we wanted to identify, and this was actually achieved by bringing also good product management that allowed for us to identify the products and redefined our product vision for the different products that we have in the platform. And we envisioned something along the lines of having product A, B, and C inside the platform, which extended the front-end layer and the back-end layer, and at the same time giving designers, giving product managers to these individual products, which would then allow them to better implement features more easily and also to deliver more value to the final customer. So yeah, we knew what we wanted to do. We wanted to split our front end in different verticals, but how were we going to achieve this? So Micro-Frontends was a really clear answer regarding this, but of course we investigated a lot. Basically, there are quite a few frameworks right now to implement or to help and guide implement Micro-Frontends. We have Mosaic 9, which is the actual implementation of Zalando. So Zalando implemented this framework when they wanted to bring out their solution to Micro-Frontends. Then you also have Single SPA, which is a really cool one. And they have a lot of documentation on best practices to implement Micro-Frontends at your application or at your platform. They have really good documentation on this. And Pyral, there are several more, but then we started thinking, and we really didn't want to add a new layer of complexity to our platform. We didn't want to have the burden of implementing a new framework and having that framework adaptation to all our platform for the front-end part, of course. So we wanted a solution that didn't require a new framework, already different than the frameworks or libraries that we were already using. Our tech stack is basically React, Redux. We also use React Rotterdam for client navigation. And then we have this on top of Kubernetes served. And yeah, so for the no framework solution, we achieved the conclusion of Module Federation. So Module Federation is a new JavaScript architecture, to put it briefly, which was launched and released together with Webpack 5 at a stable version. And it was released October last year, so it's pretty recent. There's still a lot of new content being bringing in. There's a lot of stuff still in alphas, but it's quite new, but it's really powerful. So that's the reason why we went with Module Federation. And by quoting the creator of Module Federation, so he says that Module Federation allows a JavaScript application to dynamically load content or code from another application and in the process share dependencies. So I'm going to take a while just to break 3 important points in this sentence. So Module Federation allows a JavaScript application. In JavaScript application, we here understand that this is a Webpack based application. So it's bundled by Webpack, in this case, Webpack 5, in order to get these features, okay? And then it allows to dynamically load code. This is also important, the load code part, because whatever Webpack can parse and distribute, then we can also share between different Webpack applications that code. We can share primitives, we can share like objects, arrays, we can share React components, we can share whatever is possible to parse with Webpack, okay? And then we have, and in the process, it allows them to share dependencies. This is also really important. And the share dependencies part is one of the really good features of Module Federation. And I'm going to show a diagram. Please ignore the crooked arrows. So let's imagine that our client goes to some website and he served the application A, in this case, the SPAA. Then we have loaded in that scope our React at version 17. We have Lodash at version 4. And at runtime, which is what Module Federation allows, at runtime, we see that the user needs to require component C from another application. So we request that component at runtime. And when this component is requested, Module Federation does a couple of verifications. So it's going to see, okay, component C depends on Lodash v3. So let me just see if I can drag the cameras. They are in front of the draw. Okay, no worries. So it requires Lodash v3. And I don't have Lodash v3 currently loaded in my scope. Which is my host at the same time, which is application A. So I'm going to bring this dependency because component C depends on it. And then module federation sees, okay, it also depends on date functions. And I also don't have date functions in my scope. So I'm going to bring it also. And then finally, I can bring our component C because component C will have everything it needs to work in the host. So this is how, really quickly, how module federation solves dependencies. And this is really helpful to avoid duplicated dependencies because you can see that component C also dependent on React version 17, and it didn't load it because it already had it in the scope, right? So yeah, this is really powerful. It will avoid one of the main pitfalls in micro-frontends, which is collisions in dependencies and dependencies that override global variables that that the same dependency in a different version also used. So it's really cool. And how does module federation allow us to do this? It's basically configuring a plugin in our Webpack application. And it's just like a couple of lines of configuration that allows us to do this. So here we have the name for our for the configured, in this case, for the project that this plugin belongs to, which in this case is named app shell. We can then define some remotes, and remotes means that at runtime, I want to be able to rely on these guys in items, checkout, blog, shared. And I'm also telling my Webpack application where he can find them. So I'm saying that he can find the items micro-frontend at localhost 3001, the checkout at 2, the blog at 3, and the shared at 4. And I'm also saying which file is the file that serves as a manifest. So this manifest file is really small, and it allows the host to actually know what that micro-frontend is exporting and what it needs in order to do that dependency solving solution that I showed you earlier, and what components he can bring to the host. Then you can also see that we have a shared object, and this shared object is the one that configures what dependencies at what versions and how we handle them to module federation. So in this case, we can see that we are extracting dependencies, and these dependencies are actually being imported from the package JSON. So we are importing everything that we depend on, and we're saying we want these versions. And then we have two special cases in this case, just for an example, which is React and React DOM. And we are treating them as singletons. So we are saying to module federation that under no circumstances do we want two versions of React or React DOM. We only want one, and we want one at that version, which is the dependencies.react. It's being fetched from the package JSON. So this is basically how you can configure and deal with all the module federation cool features in the Webpack project. So how did we handle the migration in the client? Because at the time we had a monolithic application, a normal one. So we had our client reaching our front end. Our front end had a client-side router, like I said, and then according to the route, he was going to be served some kind of feature and some kind of component that then would load more components. So really a normal SPA feature. And what we wanted to achieve by leveraging Webpack 5 and module federation was this. So we wanted to bring our architecture to what we see here. And what we see here is basically a single entry point, which is the app shell. It will serve as an orchestrator for the whole solution. And this is the host for the user. So it's what's loaded first in his browser. And it's what actually imports code at runtime from other micro-frontends. The solution that we want to implement is basically every single block that you see here is a different Webpack 5 application. It's deployed in a single location, in a single independent location is what I mean. So application A is deployed somewhere, application B is elsewhere, and C elsewhere. And then the app shell knows how to communicate with these guys according to the configuration that I showed you earlier. And another really cool feature that we can bring with this is, although we are separating our SPA into different applications, we are actually giving the user the same experience as a single SPA application. So because we are serving the app shell as a first resource, and because the user only gets into this resource, when we are loading the micro frontend A, B, or C for the user, it's actually like loading anything that's code splitted with Webpack. It's just a single loader, and it then loads stuff. And as he navigates within the app, he won't load it anymore. You don't have a hard refresh on the pages because you are not actually changing locations in the URL. It's really working as an SPA, and that's really cool because the SPA user experience is really good for the final client. And another thing that's really cool in this architecture is that we can leverage independent development also. So yes, this works orchestrated together, but you can independently develop each one. So the development team for product A can develop only that product A. It doesn't need to run in the orchestration. You can run this as a standalone. And then when you actually want to test integrations, of course, you will have to run it orchestrated with the whole solution, but it gives you the ability to develop in standalone mode. Yeah, so we also wanted to create a shared library because there are many components, and currently at the client, we are using this to share components like a button, an input, a card, which is common to every product. And in this way, we can guarantee that the different micro frontends get the same feeling and the same user experience, which is crucial to a good overall experience in our platform. Okay, so I'm going to just show you where we are currently in the client. We have 2 micro frontends in production. We have our monolithic, which was migrated to a micro frontend and is deployed, and we have the shared library also in production with those components that I told you about, the buttons, inputs, cards, and some other components. Of course, in the future, we want to bring this current state into the architecture that I just showed you, but it's a process. Like I said, it's a migration. And it's also important to note that by implementing this, we didn't actually stop development of features. So we continuously sorry for the redundancy. So we continuously delivered new features in the platform while we were migrating to this. So now we are in the process of splitting our first product from the monolithic that you see here. And at that time, there will be some coordination needed between the 2 different teams. But after the split is done, the independency and all the benefits that I told you about will begin to kick in. And that's really important for our team because it's growing. Okay, now I'm going to show you a demo. And I hope you understand that I can show you the actual client platform. I'm going to show you some demo which implements the same architecture, and it implements the final architecture. So you can see the benefits or how it works when it's implemented. So I hope you can see my browser. So what I have here is a clothing store. It's a really simple one. So you can list clothes. You can see the details of a cloth. You can also see a list of a blog posts, and you can also see details of a blog post. You can then add clothes to your cart, and you can purchase in the end what you have in the cart, and basically reset the clothings that you have here. So you can see here, this is the GitHub repository that is the code for the demo that I'm showing you. And you can see here in the architecture for this application, that this is implementing basically the architecture that I showed you in the previous slide. So we have an app shell, which is exported in port 3000. We have an items, which is our clothing micro frontend running on port 3001. We have our checkout micro frontend running on 3002, our blog in 3003, and then we have a shared library on 3004. So now I'm going to do a refresh on this page, and we're going to see our network, and we're going to analyze some stuff, which is interesting to explain how this is implemented in the final version. I also slowed my internet to a slow 3G in order to get easier to see some things. So I'm going to refresh now. And you're going to see here two loadings on the top. Loading and loading. And this is the time between our host, which is the app shell, requesting to the different micro frontends to bring out stuff into the host and then serving the experience. So exactly the same thing as code splitting something and then importing it, or making an AJAX request to an API and loading something and then getting the data. Exactly the same experience. We can see here that these remote entries are the manifests to the different micro frontends that we have. They are 200 byte files, so they're small. And this is what's telling our host what he can import, where, and what dependencies it needs. And then we have here the important parts. So we can see here that in the URL, we were redirected automatically to the /items. So when you go to the root of this project, you are redirected to the /items. And by doing this, the app shell requests all the code from the micro frontend for the clothing items. And you can see that request here. So when he hit this root, we requested our 3001, which is the items micro frontend, for all the routes that he has. And then we loaded them. And now every subroute that it's inside items is handled and delegated to our micro frontend for the clothes. So if you go here to the details of a cloth, like a floral dress, it's now loading more components from our shared micro frontend. And you can see here, this subroute of the items was already delegated to the micro frontend, and it was imported by the app shell in the beginning. So these imports, you can see here, body, button, body, header, card. These are shared components which are used by the different micro frontends, and they were imported when they were needed in this case. And another cool thing to notice is that with module federation, we can do something like export the whole micro frontend, but we can also export like really atomic components. Imagine this checkout cart here on the top right is as an atomic component exported by the checkout micro frontend, but checkout micro frontend also exports the whole product by itself. So you can see here that in this import, we imported this checkout cart, and the checkout cart will actually update when we add stuff to the cart, obviously. So you can add clothes to the cart and it's incrementing. And then I'm going to clear now the network. When you go to the checkout cart and you change the route, now our host is requesting the micro frontend for the checkout to bring in the routes that they use. And then with these routes that were loaded from the checkout micro frontend, we get the clothes that we added to the cart. Okay, now we can purchase them. And then we have no more items, of course. We go to the route. We are no longer loading stuff in this route, right? Because we already have everything in scope, like a normal SPA experience. If we go to the checkout, the same. And now if we go to the blog, which we didn't go yet, we can see that it's importing the micro frontend routes. And now every subroute, like in the clothing, is being handled by that micro frontend. Okay, so this was the demo. I'm now going to give you a bit more content if you want to explore or investigate on your own. So I actually created also 2 articles on the subject. You have here the QR codes and also the links. The first one explains what we wanted to achieve, the architecture and the reasons behind creating such an architecture, the pros, the cons, and everything. And then the second one is the actual implementation. So it's the implementation of the demo that I just showed you. And then on the right side, you have the code demos. The first one is for the demo that I just showed you. And the second one is like, it's an application which implements the same architecture, but it's like a playground or a POC for different things. So we are experimenting with different states of Redux for each micro frontend in order for them to have independent states, but join them together when they are on the host. We are working with internationalization and how to split internationalization between the different micro frontends and a few other topics that you can see, and you can also contribute if you want to and do some PRs, go ahead. And I also want to leave you here the link to the book. So the creator of Module Federation he created the book, and it's really important to get this information, because when you want to investigate the inner details of what shared object configuration means, on what each key means, you don't get that kind of information really on the internet right now, because it's recent. Like I said, it's October last year released. So the book fills a lot of holes in terms of theory behind all this, and it's really important to get to read on this if you want to go with this kind of solution to any project that you want. Okay, so I'm not sure if I hit time or not, but let's go for a Q&A. You can also leave the questions on the chat if you want.
Yeah, but we are changing the format, so we would prefer if people would speak, asking the questions like a real in-person meetup, because before we were using this format like a webinar where people couldn't speak, and we felt it wasn't connecting with the audience. So does anyone have a question?
I do have a question.
Hey.
Hey, hello, my name is Franco. Great talk, man. It was awesome. I'm in the ways of implementing the same thing in my company, taking our monolith and breaking down in separate apps. And one thing that I was struggling with, and then I figured out like in a way, and I don't know if it's the right way, is like how to navigate from inside one app to the other. Like, let's say I'm inside the blocks app and I need to navigate to the items app. Okay, the way that I did was that I have a router at the top on the app shell, which knows about the items in the blocks, right? And then inside the blocks, I have the base name as like blog / something, and then all my routes doesn't need to include that. And in the items, it would be the same. So when I try to navigate from the blocks to the items, I'm actually using an anchor, which causes a page refresh to leave that app. What would be an ideal solution for that? If that's the right way of doing it, or do you have a better approach?
Okay, so the approach that we followed in this demo and in the client also is something similar to what you did. So we have in our app shell, which is the orchestrator that I told you about, we have a client-side routing which knows what is the base route for every other micro frontend. So the app shell knows that the items is in /items and that the blog is in /blog. And then when the app shell detects that the user goes to this route, to this base route, that's the point where we request at runtime for the micro frontend to bring out its code. And then we delegate the navigation to that micro frontend. So if he goes to /items /something /details, that's already the responsibility of the micro frontend. And that's important. It's a really good question. It's one of the important parts on this architecture. So yeah, the base root is known by the host, and then every subroute is handled and delegated to the micro frontend.
Okay, thank you, man.
And this was possible due to React router nested routes mainly, right? Yeah,
it was implemented with nested routing, and then the micro frontend, when he gets the route for the subroutes, he already knows that he's in /items. So he doesn't need to do any kind of trickery with the URL or anything. He already knows that he's in /items, and everything he puts after that, it's already prepended with /items.
I have a question. Okay, so thank you, first of all, for shedding light on this. I actually am implementing something, but completely like from scratch without any module federation at all. Interesting enough, I noticed that you have like an application just for shared libraries. Can you expand on that? Like, why do we need that?
It's more about not repeating code as much as we can, with the expense of we may be breaking something if we do something wrong on the shared micro frontend. So the reason we did that is because in all micro frontends we have buttons, we have inputs, and they're all the same. They have all the same behaviors. They have all the same themes for the UI, for the CSS. It's JSS actually. And we didn't want to have this code replicated in every micro frontend, because when we want to change a button, we don't want to change it 3 times. We want to change it once. But then again, if you do some change that actually breaks the button, you are also affecting possibly multiple micro frontends. So one way that we are trying to avoid this is by having a person which is in charge of the shared library. This person doesn't only develop the shared library, it's a person from any of the teams. It doesn't really matter which, but he's responsible for reviewing reviewing every code that enters the shared part of the platform. And then he also has to think, okay, does this affect in a negative way any other micro frontend? Besides all the unit testing, of course, the shared micro frontend particularly needs a bit of good unit testing, at least to see if we can do regression testing accordingly to see if we break anything. So this is why and how we are doing the shared library.
Thank you. So you mean it's basically considered as a kind of components library and stuff like that?
Yeah.
Because my understanding, I thought it was like the place where you would resolve shared libraries in general. I guess my second question is, why not actually create like a NPM package with these libraries that are shared?
Okay, that's also a good question. And using NPM packages is also, it's actually considered in this architecture more like a fallback. So the main reason we are not using that is because with the NPM package, if you want to achieve something and deploy it, you need to deploy the version to NPM, and then the NPM version will be downloaded into the micro frontend. With this, you avoid that third-party dependency. So you develop something in the new button, you deploy the shared micro frontend, and the other applications that consume that micro frontend, they only need to refresh the browser, and it's already fetching the new version, you know? So you don't have like this strict import policy of a specific version from the NPM package. The only thing the host cares about is, do I have a button in the shared at this endpoint? Yes, I do, then bring it, and it will bring the latest version. There are ways, of course, that you can import and export stuff with module federation at specific versions, and you can also fall back to NPM packages. Let's imagine that our host he can't require the button from the shared because shared is down for some reason, can happen. We have fallbacks for everything, of course. If something goes wrong, we'd show us an error screen saying that, well, something went wrong, of course. At that point, we could fall back like to the NPM package. Okay, so I couldn't import my button from the micro frontend. Let me import it from NPM because I know it's there. Even if it's an older version, at least it doesn't break.
Oh, thank you. So this is basically like deployment of these components is actually something you want to also be independent. So yeah, that makes sense. Thank you.
To be more agile in the
end. Just, I think part of the reasoning here, and sorry to add this, I had the privilege of working with David on this. He did all the work. I was just watching, but it was also because. So it was organizational things too. So as we wanted to empower other teams to create new micro frontends with different products by having a shared library, which is part of the same monorepo, in which you can add components easily and so on, it was a little easier for us to, okay, you want to start a new product inside the same platform, inside the same frontend, you have your shared library, it's on the same monorepo, and we all will review it and so on. So I think this was a decision. It's not worse or best than publishing NPM packages, but just to have a little tip here.
So just a quick question. Have you ever thought of using the shared library also to add stuff that you want to have across all micro frontends, like observability, that you want to make sure that you're exposing the metrics and so on of all of those micro frontends at that level?
We are still like thinking on how we can leverage the shared library to also have those kinds of things that you're saying. I think the most ahead that we thought about was having like shared behavior, not actually components or codes or whatever, but actually shared behavior that you want. In our case, since it's a React-based application, we may share logic with some kind of custom hooks that we share with our shared library or other kinds of logic shared. But yeah, we can leverage the shared library to get these common behaviors. We're still in the process of doing that. So I really don't have much information ahead on that.
So I have a question. First of all, thank you for the presentation. A question that I have is like, you have, for example, the example you showed, the clothing store, you have 3 microservices. And let's imagine that they all use a different NPM version of React, for example, or any other NPM package. It will, from my understanding, it would need to fetch all of the different versions, increasing the payload while we are fetching those, right?
Actually, no. Because with critical versions, we are saying that we only want that version as a singleton, that dependency as a singleton. So even if we needed to have React at different versions, Module Federation would only bring it once at the version that the host had. But if you want to continue the question, I can also tell you how we are circumventing this.
No, sure, you can go ahead. It was just a question now, how would we avoid increasing the payload unnecessarily?
Okay. So basically what we are doing, and this was a decision which has its pros, it has its cons, but we are using a monorepo to hold our different micro frontends. We did this for a number of reasons, namely to get the same tooling, to leverage the same testing setup, to leverage code styles, to leverage a lot of setup stuff that it's always the same. And we wanted to do it once, and we wanted to leverage the configuration that we have everywhere in our different micro frontends. And we are also using Yarn workspaces. So Yarn workspaces is a dependency manager for a monorepo. And in our different monorepos, we are saying that for critical libraries like React, React DOM, React Router DOM, date functions, imagine, or other libraries that we consider critical, we are actually saying that every micro frontend in our monorepo will have this version, precisely to avoid Module Federation from being confused and we want these versions to be the same. So we don't want to give the liberty to the different teams to do whatever they want. We want them to be faster. We want them to have more independency. We want them to be able to release independently, but we also want to maintain consistency in the platform. And this is one way to do it. And this is what we did. So in critical versions, we are saying for the whole monorepo, which version we want. If by some chance, some micro frontend needs a specific version of something, then we need to study it. We need to see if it justifies the change. And then if we see that it justifies, we need to change the different version in the specific package JSON for that micro frontend, which comes with its pros and cons. So it depends. We would need to imagine that it would be React. We would need to remove the singleton part. We were then opening doors to have multiple versions of React in the same scope, which possibly will go bad.
Thanks.
We have one more question regarding the loading. It's in the chat. Do you use React.lazy to load the micro frontends?
Yeah, so every component loading and every import that is made at runtime from other micro frontends is leveraging the Suspense API. And to leverage the Suspense API, we are using React Lazy, yes.
Nice. Does anyone have more questions?
I have another one, if I can. Cool. So about unit testing, like if I'm testing something inside of app A that relies on something on another app, okay, at the unit testing time, that other app doesn't necessarily is up, right? Isn't necessarily up. So how do you do that? Like you mock something to avoid, or do you always need to make end-to-end tests, having all the servers up? How does that work?
Okay, so let me break that into two parts. First, if you are testing something that reaches two different micro frontends, two different domains, that's probably already an integration test. But other than that, if you need something that's imported by other components, let's imagine, and we have this case. So in our application A, we are importing stuff from the shared micro frontend. And of course, the testing environment doesn't have the components that are there because he doesn't know how to reach them at runtime. We then mock the component. And this is actually an ongoing process to improve this because the mocks are really stuffy. They have a lot of things, and we wanted to simplify the mocks. But at the current time, we are mocking everything, and we are also mocking the imports. So there's another thing that we do because the dynamic imports with React Lazy are really long. We actually developed, and Alexandre wrote an article on that. We actually wrote a Babel loader extension, which is an extension that enables us to rewrite the react.lazy parentheses import from someplace. All this, he writes it in himself, and we just import it like we usually do. So we write import button from shared/button. And when this loader detects that we have an import with shared/something, he then transforms it into react.lazy. So that's also like a time saver for the developers. They don't have to worry as much. So how would I import stuff from shared? Well, just import it normally and we handle the rest. And we just mock in our jest environment. In this case, we mock that root shared/button. We then mock it to return a mocked button.
Okay, perfect. Yeah, because I was imagining exactly the shared thing. Because like in our project, we have like an MTI module to have the components library. But as you have an app just for the shared library, then I was trying to understand how that works. Thank you, man.
You're welcome.
I'm going to ask one more question. Sorry. I know you've had so many questions today, but I wanted to ask you a question, then I forgot. Now this question remembered me, and I think it can be interesting as a segue to Franco's question. It's regarding integration testing. Is it easy to do integration testing between both microservices? To what extent, how far can you go with this integration testing? Is especially for things that need to go across scopes, is it easy to test that?
So that's also a good question. It's one that we still haven't implemented on our platform as like an integration test itself. But my answer to this would be to first, before like writing integration tests between the different micro-frontends in the code, like white box testing, I would rather do end-to-end testing between the different boundaries. And then when I have the flows tested, I would then probably think, how can I integrate this and write tests that are white box between different boundaries? Because I don't even know if it makes sense. Because if you are developing product A as the team that's developing product A, you don't need to test stuff that's in product B. So you only need to say that in the boundary that I have, I'm giving the properties, I'm giving the data that I need to give. If someone is not consuming it, right, it's not my responsibility anymore. So I do the tests in order to test if I deliver data correctly. If I deliver data correctly, my responsibility ends there. And then product B also has the responsibility to write tests to see if by getting this data, even if they need to mock it, if I get this data, which is what I'm supposed to get, do I get the results that I want? So that's probably how I do it.
And on this, I think the Cypress end-to-end tests thing is how we would cover this. So we have Cypress in place. It's currently on the process of updating it so that it accommodates all these changes with micro-frontends. But I think that's where we'd go after the jest layer, where we unit test each one of the micro products or micro frontends, and then you have to be relying on Cypress end-to-end tests, which we did when we had a monolith and we are in the process of transitioning.
All right, awesome. I think we can finish here. Thank you so much, David. It was a great presentation. I just want to say thank you to everyone that reached out via direct messages. I ended up networking a bit more than I expected during this meeting. So it was really nice feeling a bit more like in-person meetups. That was amazing. And I encourage everyone, if you know other people, just message them, try to do some networking. I just want to say that during this presentation, I managed to talk 2 people into giving me new presentations. So I'm taking the opportunity to ask for more speakers if you want to, please just contact us through Meetup, through Slack, through WhatsApp. We are always available, even first-time speakers. We encourage people to speak. We will mentor you if there's any need for instructions on how to set up slides, good slides practices, reviewing your presentations. In our team, we have a lot of senior developers. We have experience in presentations, in organization. Just send us a message, we'll help you. And it's always great to see the attendees participating and interested in all of this. So thank you so much, and we'll see you next time.
Thank you. It was great. See you.
Thank you.
It was nice
Thank you, guys.
Thank you.
Bye. Thank you.
Thank you.
Bye.